Well, hello everyone. Today we're going to talk about exploring creative paths for DLC generation. And well, let's start with this. Picture this: you just finished a video game that is the best video game that you have ever played. And actually, you discover your ideal game, even the type of that was like the best for you. But this experience, like everything in life, has to end. And you want to continue playing this new game, but you want to continue exploring or getting like new areas. But what are the possibilities that you have once that you finish this game? Well, there's a lot of video games in each genre, so you can search for a similar one. But probably will not be the same because it has different mechanics or a different lore that will not satisfy your necessities. So you can also play the game again. Some place has a higher difficulty, but again, you already passed this game, so you will have like the idea what is happening. You probably will not enjoy like the same. Fortunately, we have a third option, and it's that wait for a DLC. And probably there's not a thing that will happen, or it will. It depends. So it would not be cool that we can solve that problem. We can. This talk is about that. This is going to be the table of content. We're going to start with what's a DLC, and from that we are going to go through the path that I have been working on. Well, what's a DLC? It's a term that is used in the video game industry to refer to additional content that can be downloaded and add to an already finished game. You can think the DLC as an extra chapter of a book or a bonus scene in a movie but for video games. DLC can extend the experience of the game. It can provide an extra income for the companies or the developers, but also that can be used to improve or maintain that game, but also to generate a community or getting more content for the player. Here I'm gonna present some of examples that I consider interesting of the DLC. Here we have The Witcher 3. This game was released in 2015 and got the award of the Game of the Year by the Game Awards. And after that, they released a year later a DLC called Blood and Wine. And the fun thing is that this DLC obtained a Game Award as the best RPG game. And it is an interesting thing that the DLC was able to got like the different parts of a game and be considered as a one. We have another example here that is the Don't Starve Together. This game was released in 2014 and has been different DLCs that add new mechanics, new enemies, and basically it's extending this type of game. And that maintains the community interested in this game. Here, a small example, that is the Hollow Knight one, was released in 2017. And the DLCs came a year before that add the Grim Troop, that adds new areas, new enemies, and the Godmaster that basically add arena area for playing again against the enemies. But what are the problems that can be appear with this generation of DLCs? Well, this concept is commonly applied for gaming studios that are equipped with resources to generate DLCs. This landscape becomes more challenging for small studios. Sometimes these small studios are composed of one or two developers, which difficults the investment and creating new DLCs or new content for the players. Or also there's like an extra challenges, like the departure of a key game developer or maybe the studio is already closed. So these tasks become a formidable change to generate new content. So what's the big idea for DLC generation? Basically, came the idea releasing that we will have like a finished game. We will put it like inside of a black box right now. And we will tame a new game with new mechanics or something completely different. And this thing, it will be not just great for the companies because, well, they will get extra incomes, but also it will help to the players. That is the big reason for me. But as everything, also in the research, that is not easy. We need to start from something. And with this, we came with a pitch on that developing this type of system. It will be like different parts, given that the video game is something extent that are composed by different parts of it. It is just not like put it inside and pressing a button and will be part. We need to analyze like the different areas of it. And here we consider one area that will be the theme. This part, I think that is like, well, in the video games, different video games have parts like the water area, ice area, forest area, and some of these things interact with the mechanics. So it is important to analyze how this interaction occurs and how could be add more to it. Another thing is the game mechanics. These are the rules and interaction that define how the games play. It is the fundamental system that shapes the player experience by adding the actions, the challenges, the rewards, overall is the structure of this game. We also have the level design that involves creating the environment or the challenges on these structures so the player can enjoy that experience. Because these areas will also guide how the player experience is performed. And finally, we have art. That essentially, art is the creative aspect of the game and also evokes the emotion of the player through this game. And it is also a complex part in the area. We will talk later about it. But what we can do with all these things? Well, how can we start getting parts of this? In order to generate new structures, we need a way to connect these new areas. And for that, we came up with the idea of reconstructing existing levels through level embedding. This paper was presented in May 2023, and well, it's going to talk more about it. Here in this paper, we introduce level embedding applied to procedural content generation. We apply techniques of image embedding. In this case, we use an autoencoder and a unit. We're going to talk more about it later. And finally, we found the results comparing the autoencoder and the unit that we also going to talk. But first, let's start with what is image embedding? Well, image embedding is a processing technique that is used to restore or reconstruct images. You can think this as a smart way to completing a jigsaw puzzle by using the information about the surrounding areas or the missing areas to generate these new things. Here you can see in the example of the image, like that you can remove areas or also add new things. But how does this can be implemented to the video game area? Well, here we have part of a map and also a missing gap that is there. And that we want is to reconstruct that area. And here at the beginning was to just reconstruct it, but the idea is we'll later to introduce that new areas generated to it. And as I already mentioned, we use the autoencoder and the UNet networks. So for the autoencoder, it's a type of neural network. It is using unsupervised learning, and his primary purpose is to learn the efficient representation of data. You can think this as compressing an image, getting a compact representation, that is the latent space, and we use the decoder to try to reconstruct again that image. And the second that we use is a UNet, that is a specific architecture. There is also a neural network, but this is for image segmentation tasks. It is used in computer vision to identify and classify different areas of the parts of an image. And well, it is specialized to identify components of an image. But why we use these two elements, given that right now there are more complex architectures outside? Well, one problem that we have with video games is that we don't have enough data to train the models. So we use models that can be adapted to small amounts of data. And here we can see some of the results. To the left, you can see the VGLC dataset that contains different games. In this case, we use the Super Mario one. Then you can see the mask that we add to this dataset. The mask, we put it in the down part of the map, on the image or the levels, because it is not happening too much in the top area where it's probably more sky than anything. And finally, you can see the reconstruction of the autoencoder and the UNet. But in order to obtain this, we use different evaluators. So first, to the left, you can see that we use practically all the tiles in the map. In the second evaluation was using all the tiles of the ground, the different structures, and the enemies. And finally, the third one is just using the structures of the game. And we came with some results of it. We found that the autoencoder outperforms the UNet in practically all the different metrics. To the left, you will see the different metrics, and the different columns are the different levels that we test. But also, we found that the UNet was better by identifying the structures. That was something interesting to get and to understand, because, well, at the end, we want to identify these structures and add new ones to the game. And that was a part of the level design. And this gave us something in the level design, but now we need to talk about the game mechanics. That is another important thing. And for that, we're thinking on generating new mechanics that can be used in addition to existing ones. And for that, we're going to talk about the mechanic maker, reinforcement learning for evaluating generated rules. This paper was also presented in May 2023. And well, here we're going to start with the ultimate game designs, the strives to generate autonomously rules that make the game efficient. Also, traditional AGD methods lack of dynamic adaptability with human learning. So the algorithms that are used doesn't represent how a player works or how it interacts in the video game. And for that, we use reinforcement learning as an evaluator for their rules, because we consider that given that the training of the reinforcement learning, it can be similar to how the player goes to pressing random buttons and trying to get how these new mechanics works. In order to do this, we need to start to getting an environment. And for that, we recreate Mechanic Miner. Mechanic Miner, it is a paper made by Mike Cook. This paper was first introduced in the Flash environment, but given that Flash doesn't have any support now, we use this same model to get in Unity. For that, here we can see that we have our player or the character. There is a T shape in the environment, and the goal that in this case is the code. Here, with the original mechanics that this player has, it is not able to reach this new goal. So we need to generate new rules that will allow us to get through the goal. For that, well, we already have the environment, and we need to go to an stochastic research to obtain new rules. That these rules can be evaluated by the RL agent, and we continue in this loop till we have like something interesting for us, some rules that will be interesting for the players to use. And we compare that versus an A-star agent. Here you can see that one of the rules that is like a double jump, basically is teleporting through the y-axis. And we can see how the difference are between the RL agent and the A-star using this rule. You can notice that the RL agent used the rule just at the beginning of the environment. Meanwhile, the A-star agent tried to use like getting closer to the goal because that will be more efficient. But the players doesn't try to use an efficient way, at least that you are like a speedrunner or something like that. Here we can see some of the results, the different rules that we obtain. In the upper part, we can see the rules from the RL agent that are composed by the name of the variables, the comparators that we use, the values for that comparator, the effects that will be applied for that rule, and the value of that effect. And if you notice that the A-star agent doesn't have like different rules, is because the star agent found that these were like the most optimal new rules that would be used for past this level. Meanwhile, the RL agent found different options or different rules that can be also applied. And here, I would like to talk more about one of these in specific, that is the speed rule. Because if you remember the environment with a speed rule, it would be not an easy way to get to the goal because, well, there is an obstacle there. But when the RL agent was training, it seems like found a glitch through the Unity environment that allows that if they gets a high speed, it will be able to go through the wall without any problem and reach the goal.
Question?
Yep.
I'm not quite tracking. What are the rules that the agent and an RL agent has a set of actions that that agent can take? They're predefined, right?
Yeah.
And when these rules was you can go through walls. That was part of the initial game.
No, that's not part of the initial game. The basic rules that the ones that we start was like just moving to the left, moving to the right, and jump. And with those rules, we use the variables or the public variables that are in the game to analyze like how can we add extra things to that. Like here in the rules, for example, we see that if the speed force is equal to 20, it will multiply that effect of the speed. Right?
So this is a new action that didn't exist before?
Yeah, that's yes.
And why not build an action that goes from the start to the finish automatically?
It is not possible to get to the start to the finish automatically. Or you mean to teleport like directly to the...
I mean, what are the constraints under which you generate these rules, these new actions? I'm not quite following that.
Oh, well, the constraints is to find something interesting, or basically the idea is that with these new rules, we will be able to reach the goal, because at the beginning, it is not possible to do it. Well, and some of these rules were interesting. Some of these for the A-star agent were like similar that we consider that, yeah, they are new, but still would not add something new through the game. And getting to this, Now that we have a player character and these new abilities that can be added, we also want to add new entities. And for that, we came to the idea of enemy generation that is still under construction. But here we're going to talk about that enemies and boss generation. That is one. Yep.
Sorry, before you go to that, so how do you define the rewards for your RLEs? And when you said generating a new action which is interesting, so how do you define interesting? Is there a human saying this is interesting to play?
Yeah, well, for that, we consider a rule that it means if the agent use like similar times, like the old rules and the new rule, it would be something interesting because it's in a balanced way used by Odo. It is using the old and the new thing. If you, well, in this case, if we came with a rule that it would be used just once, like teleporting to the wall, it will be just the use of the new rule and not using like the old rules. So it will be not interesting or no will be add something new to the game.
You bring down that criteria of interesting means. Is there a definition you have for interestingness of a rule?
Yeah. Here, in the case for the enemies and boss generation, that is an important thing on a video game. Well, and also there's games that doesn't have enemies, but some of them, it will be boring if there's not like more difficulty added to them. We want to generate enemies with these new mechanics that we have already in mind. So here we have a Goomba that is an enemy that can be killed by the basic rules. That would be like move to the left, move to the right, or jump. We want to create we have here a different enemy that if you jump over him, it will be not like a good way to kill it. So we want to generate these new enemies that will use these new mechanics for it. Here we search between the prior work and we found that it is focused more on the boss generation and understanding how these four boss battles interact between them. But we want to start with something simpler. In this case, we already have our environment that the agent can travel and move through it. So we want to generate an enemy. We use here a grammar in which we can generate parts of the enemy through it. And we obtain some of these results. In the upper part, you can see that, well, we use square here to represent the enemy because it will be a simplest way to do it at the beginning. And the yellow area of the enemy will be like the weak part that needs to be hit in order to defeat that enemy. And in the lower part, you can see the player or the character interacting with these new enemies. These enemies were generating randomly at the beginning. And we found that in the lower to the right area, the bigger enemy will be not an easy way to be defeated if the agent doesn't have like a double jump on a way to reach this weak point. So for that, how can we improve the generation of these enemies, not doing like randomly? We came with the idea of using something similar to NERV. NERV is a deep neural network, which is a kind of AI model that is used to represent 3D objects or 3D model using just 2D images. Then with that 3D model that we already have, we can obtain new 2D models to this new, well, we can obtain 2D models using that 3D representation. But how can we apply this to an enemies? Well, for that, we want to do, rather than a 3D object, we want to represent a 2D enemy in this case. We're going to use the feedback of the player to generate enemies that can be defeated only by the players that have these new mechanics, but not the old ones. So as a nerf used 2D images to represent a 3D object, we will use the feedback that we obtain for the players defeating their enemy as the feedback for the enemy generation. We have different parts here. That is the velocity, the position, and time of the player and the enemy. And with this thing, we will generate new enemies that, well, is still work in progress. And we have to be trying to generate these new enemies. So the last part that I would like to talk about in this lecture is that once that we have structures that the level design in the level design area, we also need to generate balance to that game, which is something that is needed. And for that, we are working on map balance. The idea that we start was with map balance for multiplayer games, because multiplayer games require like a crucial and enjoyable experience through the maps. Sadly, sometimes the companies generate maps that are not well balanced, or they take time to go through this process of balancing these maps. And here we have different examples of games. These are multiplayer games where two teams competing between each other. And we have also different type of maps. Here are 3D maps, but what is the 2D representation for the Splatoon 3? That is a Nintendo video game. The map basically is a mirror map. Half of the map is the same for the two teams. But for other games like the Valorant or CSGO, the maps are more complex and need to be more carefully adapted to be balanced. The idea came with this Splatoon 3 that looks really a simpler way to analyze the maps. But given that we were working already with 2D map video games, we want to do something in that area. So for that, we want to use the 2D maps and use the balance of it. And in order to do this, we want to use nerfs in this case again. But here, in these papers, the nerf, once that they have the original representation of the 3D representation, that in this case is the white bulldozer and the skeleton, they used recoloring techniques to texturize using different paint jobs that you can see in the bottom part of each area. The thing that we want to do is, instead of using this visual information, we will insert information about the balance or the map difficulty or challenging. And well, this is the full picture that we have right now. It's something that can be also added to new parts, and something that it would be not easy to do. For me, as a PhD student, I will focus more on the game mechanics, but I want to introduce this in order that maybe some of you have any idea on how you can apply this to art or another areas, that it will be interesting to talk about it, because, well, it is not an easy task to do. And further, if you have any question, please let me know.
Thank you so much for the presentation. Really interesting work. My question relates to the first project you presented about level in painting. I thought the evaluation metrics were really interesting, but I noticed in the third one, you had structures, but not enemies. Can you explain why you decided, or did you decide that that was the evaluation metric, and why?
Well, the evaluation metric for that area is because I consider that in order to blend to new areas, the important things are the structure, given that you first go through the structures and then put the different enemies in the map. So I consider that was like the most important thing to identify the structures and how they are placed in the map.
Interesting. That makes sense. Thank you.
There's a fundamental trade-off between trying to replicate the same game and a different game. And obviously, you could start with a game and you start from chess, and all of a sudden you get to, a completely different game. What does it mean to be similar enough? What's your criteria for being close enough that it's the same type of game, but different enough that people want to play it?
Well, in that part, I consider that in order to generate a new part of the game, we want to be like similar because probably the original game has some mechanics or some visual art or some game design that the artists add that we really enjoy. So we want to extrapolate that similar things to the new area that will not be just like something completely different, like a new game, but it still will be like a blend of.
No, I agree with that. I agree that there's tension. It should be similar, but not the same. How do you quantify that? What's your criteria that says this game is sufficiently different that it's different?
Well,
Sufficiently the same that people want to play it.
yeah, I think that, well, I'm still working on that. I think that is something really difficult to identify. How can I measure this part of the area? But yeah, I think that I will continue working. How can I measure it?
I'm curious why you have such a focus on making new mechanics, because not all DLC actually introduces the mechanics to the game.
Well, that's true. And not all the DLCs have new mechanics, but when I was with this idea, I found that the games that I really like have new mechanics. So that's why I consider that could be an option of add new mechanics to explore that new areas.
I'm gonna ask a question to try to get you to answer Russ's earlier question. So how do you actually generate the rules when you're generating mechanics? You can go back to the slide that has the rule generation on it potentially. There we go.
Here, well, we analyze how this we search for variables that are public in the video game. We use the stochastic research to modify some of these values, and for that we obtain these new rules. And with these new rules, we introduce to the RL agent that can be trained in this new environment. And we found that, or we identified that these rules should have something new need to add something new to the game.
Sure. So does the stochastic greedy search change the variables directly, or is it generating rules that change those variables?
Sorry, could you repeat?
Sure. So you said the stochastic greedy search is going to change the public variables.
Yeah.
Is it that the stochastic greedy search changing the public variables, or is it generating rules that change those variables?
Well, we use to generate new rules that can modify these variables.
Okay. And then the stochastic greedy search, how does it know what a good rule is?
It doesn't. Just greedy.
So the rule that says player one wins all the time.
Well, if it's greedy, that suggests it's greedy in terms of something. What is it greedy in terms of?
Oh yeah, it is trying to get the best reward, in this case, getting the best punctuation in the environment.
Mm-hmm. And how does it get that?
We're a little bit lost here.
How does the stochastic greedy search know when it's found a good rule? What does that look like?
Well, it is when it is balanced between the old rules and the new rules.
Oh, so it does have a sense of what a good rule is then.
Oh yeah.
Yeah, cool.
How do you quantify that? Is it 0.7 times old plus 0.3 times new?
Well, like maybe I'll ask a question a little bit differently. Like number of moves during a second, is that, or difficulty in achieving the goal? Like, what are some other metrics that, because if I'm playing a game and I go in there and it takes 2 seconds to solve, well, that's not very interesting. So one mechanism of greedy search would be, oh, make it interesting because, you know, the guy spends more time trying to accomplish the goal. But then if I spend an hour in it, well, that's not very interesting. It's boring, right? So you kind of want to balance, like, how many hits do I have to make in order to defeat the enemy? How many steps do I have to make? How many movement changes do I have to make in order to achieve my goal? Like, those are all metrics that you could use in your greedy search. What do you use?
Well, in this case, I use first how many times the agent is trained with the old rules. But in this case, with the old rules, it's not possible to reach to the goal. So with these new rules, should be like a balance between the old and the new rules. I would not say like a 50-50 times would be something really good for this new rule, but in approximation, it will need to be used like 2 or 3 times to reach the goal.
So there's a range of like ratios. That's good.
Yeah.
So I have another question. I'll ask the Chat GPT question. Can you use Chat GPT to generate narratives for your games?
Well, I haven't gone through the area of narrative for the game, but I think that would be something interesting to trying to go. But I have not focused on narrative, and I'm not an expert in that, so could be used, but probably for something simple, but not something that will have like a lot of balance or something similar for the video game.
I have another question. There's these 4 blocks that you say define a game. Do you have any future plans to look into how you would generate different themes? Or is that something, or you said you were more interested in the mechanics, but have you thought about the theme part of it?
I have think on it, but I think that that was given that this was like the basic idea that I have, probably the theme would be not part of it, or probably would be part of it. We know that the art can be extended into images, music, and other thing of areas, but I don't know if I will have time to get through the thing.
That's totally fair. I was just curious.
Can you go back to the slide where we're comparing the results from autoencoder and unit?
Yep.
No, you're like previous. No one's taking a scene from Mario. Yeah.
Yeah.
So I just noticed in the autoencoder one, there's that, I don't know, in the right side, that singular block is missing from unit. Is there any special reason why it's missing?
Sorry, which one?
In the first row, third column, for autoencoder, and the first row, fourth column, I'm seeing the block is missing from the right side.
This area?
Yeah, so you can see there's no block here, but in the left side, in the right side, when you see the image from unit, there is that block there. Is there a reason that block is missing in the encoder switch?
Staircase.
Yeah, so
Okay,
Yeah.
staircase.
the upper one. Yeah.
This, okay,
The upper row, one row above, one of the 2 Goombas.
these 2.
Yeah.
If you look at the unit and the autoencoder, there's an extra block on one side and there's not on the other side.
Okay, yeah, in this case was given by the autoencoder that at the moment of compress the information, probably to replicate would be like putting down there. But you can see that in the original one should not be there. So it keep the structure coherence there. So that's what I think.
Thank you.
If there's nothing else, we go ahead and thank Johor again. Have a good day.